See my screen, right?
Yeah, it's coming up.
Okay.
Yeah, it's
Okay, so like where we stopped last time before we had a bit issue, technical issue. I was trying to explain, like I said, we got here when we are doing unsupervised classification, and now we want to do supervised classification. Now, if you look at this imagery, based on how many you want to classify, you can see here that this is a residential area. Here you have something that looks like a bare soil, or here farmland. Then if you look here, you see that we have something like water body here based on the nature or the way this is designed, as in the imagery is looking at. Then if you look here, you see we have water body here, and then if you look here, you see we have a kind of wetland around here, and then also part of water body here. So looking at the imagery, you want to know how many ways you want to group depending on what you are interested in. Now for us to get that done, I started like with the introduction of several few things like what we are going to be used, like the imagery we are going to use, and also the tools we are going to use. And I mentioned that we are going to use image classification, which if your own is not activated, so you just need to right click here. If you right click here, you will definitely see image classification. So when you right click here, you will see image classification, so you just need to check this and you have this here. Now one of the things I want us to notice that when you are doing a classification, you see here I have a lot of raster here. Every raster that I have here are listed here. So make sure that the imagery you want to work on should be the imagery that will be here. So that is the layer. So make sure that you have to select it. So the image I'm going to work on is this one, Landsat 8 2022. I have to go there and select and make sure that that is what is selected. Now here, if you go to spatial analysis tools, which you have to go here, if you go add toolbox, go to spatial analysis tools, go to multivariate, you will see the band collection statistic, class probability, create signature, then Garam, edit signature, ISO cluster supervised. This is what we used last time, maximum likelihood and principal component. I have explained this to us in our previous section, but what I just want us to know here is that make sure that this is selected, and once this is selected, make sure that here, that is the imagery you are working on, that is here. Now if you look here, you will see the tools, which is training sample manager. When you click on it, we'll use that to train the imagery. Now if you click here, you will see here where we have draw, polygon, then draw rectangle, draw circle, and select by segment. So this is the way you can make training. Then another tool here is create viewer window. When you click on it, like I was trying to explain last time, you see here the way it is. If you click and drag here, it's going to bring up a pop-up window that is going to zoom close for you. So you can also adjust the zoom, like for example, this is 1:52,000. If I make it 1:100,000, you see how small it is. If I make it 1:1,000, you see how big it is. Then if I make it to 1:10,000, it brings it like this. Then if I make it to 1:24,000, it stays like this. So is based on you. 1:100,000, it stays like this. So I can also change it to how I want it, or click on this to increase, or click on this one to decrease. So with that, if you any place you drag, you will be able to see what is there, very like zooming in very well. So on that, I'm going to zoom close by removing this. Then I click on this and I will see magnifier. Now it is the zoom, then this is magnifier. So I select magnifier, that return back. So that means if I select this, is now a magnifier. You can see it on top here. If I select this and drag this imagery here, it makes it smaller. If I select this, it brings it up. So on this, let me zoom to layer. So I zoom to layer, so you can see whatever I selected is very looking big like this. So this is it. So if I want to close it, I can click on this and that will be closed. Then I'll click on this to drop this. So now we are going to train this imagery so for land cover classification. Now depending on the number of classes you want, this is where you need to train it here. When you click on it, it will open Training Sample Manager. Here, this is where you clear the training sample. Here, this is where you load. If you have already trained before, or if you have already done training before with the imagery, you can always, anytime of your choice, load it. Like if I click on this, you see now it will open the location where I have the training. So if I have already trained, you will see it there. Then here is where you save the training sample. Here is where you merge. Here you unmerge. Here you delete the training sample. Here you move the training sample up and down. Here you move it down. That is between using this. Here is to reset the class value. Here is to show histogram. Here is to show scatter plot. Here is statistic, and here is to save the training sample. So we are going to be using this. Now on this here, you will see different method, which is draw polygon, draw rectangle, draw circle. So we are going to be using them now to make training. How do you train? You have the imagery, and then you already know what is here. By looking at here, you see this is residential area. By looking at here, this is residential area. Looking at here, this looks like water body. Looking at also here, you will see that this looks like a water body. So you now use this to train it to understand what is here. So on this, I'm going to use, first I will start with normal rectangle, polygon, sorry. So I'll click here and go here where we have polygon and click on it. So it means that if I draw it here, I am trying to take this satellite imagery. Remember, this is selected. If I draw it, I'm trying to take satellite imagery. Any place you see this place, just know that it's urban, because it looks is an urban area. So I'll go to another place. Any place you see this, know that this is a built up area. And you can see here it can have class 1 and class 2. Now I will go to another place again, and then zoom close here. Like you can see here, this is a residential area reflecting like this. Then I will say any place you see this kind of a spectral reflectance, so just know that this is a what, this is a built up area. So you can say I have 3 classes here. So here I can click here to edit, and I'll put it built up. So I'll type it build up. Then here as well is built up. This is built up. So this is where I want to use these tools, which is merging training sample. So since I am making many samples, training many samples, I can select this and select shift. I press this, I'm holding shift, and then with this I can merge it as one. So it all of them have been swallowed as it form one as a training sample, one training sample. So if I go down to another place that I know that this is a built up, if you see here, this is not a built up area but looking like a bare soil. So I will go to another place again, like for example here, this is another built up area. Then I will go here now to create a training sample here, and say any place you see this with this reflectance color, know that it is a built up area. Now I will stop. Then this is it again. I can hold shift again with this one and merge it with the training sample. You see here, anytime I merge it, the count number will increase. You can also change the number. Maybe you want to make it red. You can see here that any place we have that training sample looking red, you can see on the entire imagery. So I will go here again and go close to this place. You can see this is residential area. All these places are residential area. So what do I need to do? I will now look at this. You see this one look like off and on. So I will look at this again. I will try to tell you, any place you see this, know that this is a residential area. Any place you see this kind of color, know that this is a residential area. Any place you see this no spectral reflectance, know that this is a residential area. Now with this I have actually done many, so now I can also hold shift and measure all of them to build up area. Now this is the first segment we see. Now another segment we are seeing again is water body. Now this water body here, you can see the water body here, there is a bridge here. So I can now select this water body like this. Any place you see this reflectance, just know that it is a water body. Then I'll go to another place. Any place you see this again, just know that it is a water body. You can see this is a water body. So I can click on it. This is a water body. So I will go over to another place again. You can see here any place you see this again, know that it is water body. So I am now training the imagery to understand that any place you have this kind of color or you have this kind of, just know that it's a water body. So this is exactly what I'm doing. So I'm getting on this. So now I will select this to the end like this, and I will now merge it, and then I will write it maybe water. So let me just put it as water. Then I will continue the training again. From here you can still see it here. Now this is water. Then I'll go down to this other side again, because I want to make it in different places. So here you can still see the water body here, so I can click on this to now make this looks like this, and then this water body. Now this is a bare soil. I want to assume this is a bare soil, though this is a sand, but I want to say this is a bare soil. So I want to like train it up like this. Now if you look here, you see that I jump this. Now this is a bare soil, so let me make it as bare soil. Now here I have water here. Then let me go here again, and under it I'm going to train another one. Select this one as water body. Now you see now that this is water body, this is also two water body here. What am I going to do now? I'm going to use control. I'm pressing control now to jump this bare soil, and with this, and then I'll click on this to merge it. Now while the bare soil is independent, so it's not on top touching the other one. So you see now that I am able to make different training, so having different classes. So if you also look here, I can choose, because this looks like more farmland, then I can choose this place to say this is farmland or vegetation. So if you look here now, you see that this is a farmland based on the way it looks. So here I have also a quiet place that is residential area or built up area again. So I have to like add it up here, select one and the last one, and then I'm going to merge it, and then become built up area. Here let me assume that this is a farmland, because the color is a bit over, so I'm assuming that this is a farmland. Then also the same way again, this is a farmland, so let me also make it like it and say this is a farmland. So here I can now go ahead to say here is farmland, so I'm using farmland here, and then also selecting this, and then selecting this last one and merge them as formula. So if you see now, you have 4 classes here. Then another thing I can also do is ranging based on this. This is a water body here, but because it is shallow, it is showing a kind of color different from other. So I can go here to now identify this as water body, part of water body. Like if you look here, see that this dark area looks like this, have a kind of vegetation, so the water body follows that path. So I can make that training like that. Then going here, you can see that here we have a vegetation, so I can make this, for example, the one that looks like this. Now this looks of more vegetation, for example, so I will go here, and then let me use this one as vegetation. So this is vegetation, so I'm also going to make this one again as well, and then let me also select this, and then select this one and merge both of them are vegetation. So you can see here that I have about 5 classes. Now let me use some of the tools I am talking about. I was trying to explain to us in the beginning. So I'm going down here again, and you can see there is a thick kind of vegetation here, so I'll go here to make this also a vegetation, so which is exactly what I'm doing. Then I'll also use this again to make this vegetation. Now this, and holding shift, I will merge it and become vegetation. Now I want to talk about bare soil, so I want to assume that this place here, this is a place we have bare soil. You can see the scatter vegetation and rest of it. So if I select this place now to be bare soil, then we see now that if I select this and merge it with this and together, you see this is bare soil. So from all indication, you see that from my training, the bare soil have about 1,800 count, meaning I have about 1,800 pieces. I'm trying to say this place is use this to understand where we have best soil. So for this, I'm also going to another place here and also make this kind of draw and say this is a bare soil, so I can select this and this now to merge it as one. Now if you look at the bare soil, assuming I want to unmerge it, I will select the bare soil here and I will click on this. Now you see this bare soil 1, bare soil 2, bare soil 3. I've already scattered them, like unmerged them. If I want to merge it back, I will click on this and still merge them back again. Now it is showing bare soil 1, so I will probably make edits. Now under here, when I click on this, like here, you see this is id, this is values. So if I want to reset the value, this is 186 based on what it is, so I'll click on this and this will reset it normal from 1 2 3 4 5. Now if I want to arrange this in alphabetical order, I can always click on number 5 and I can move this up like this. Bare soil, build up area, and I can also move water body down, and then vegetation here, farmland here. So you just see like I'm trying to make a kind of arranging it in order. And you see now I've scattered this, I can also click on this now to reset them like this. So once I am done with the number of training or however I want to make the training, I can click on this to save it. So I want to save this in the location where I save this, so I can make this and then I'll say training sample here and I'll save it. So what it means, since it is saved, what it means is, okay, sorry, I want to also make something like when I was saying training with a shape. Now look at here, if I click on this here, I can also use rectangle. So it means that if I use a rectangle, you can see the way I draw it, so it goes into rectangle. So let me also add this to bare soil and merge it together. And if I want to use circle, I can also go here to select circle, and I can use this to draw the circle here, and this also comes a training sample way. So I will also click here to merge. So I have used both polygon, rectangle and circle to show us how we can train. So with this, I have trained in different places, like you can see here, train different locations. So the next thing I can do, I can also save it, like replace it with what I've done. So now you wish to replace, and I will say yes. Now it has been saved. Now the next thing I can do is that I can clear what I have by using these tools. If you click here, you will clear the training sample you want. Assuming I have trained this before and I want to bring it back, I can click here, click home, and I can click this to open it back again. Once I open it here, it returns back. So as you can see, now the next thing I want to use here is to save create a signature. When I create a signature, click here, it is able to ask me where do I want to save the signature I want to use. So I can now go to where I want. So let me go to where I saved it here, in document, and then I save it here, and wherever it is, so let me assume home. So if you click on this and then say you want to save it, and then let me put it here and write Kingsley. So so this is it now, so that automatically will save the signature. So I'm trying to save the signature that we have created, like the way it is. So once it finished saving it, now you can now go ahead to run your maximize likelihood classification. So what we do now is we do supervised classification. So you are the one telling it this is what it is. So using the spectral signature, or using the way the image is showing, so I want you to give me maximize that, use that to give me the rest of other places that have the same kind of look. So as you can see, we only train 5 of them, and the 5 we train is those ones you are seeing. So we only have 5, which is exactly what we train as 5 classes. So we are going to use these 5 classes to now use it to do our maximize likelihood classification. Are we together? Do you have any questions so far?
The training, I don't understand it properly. Maybe I'll go back. I would understand. Is it the training? Is it this process that makes a difference from? Unsupervised.
Yeah, this is what makes it different from unsupervised, because in unsupervised, what you did is that you say, okay, randomly, based on the number of classes, give me this into 5 classes. So the algorithm now will look at 5 classes based on the way the imagery is, and able to say, based on this, let me make it into this number of classes. So it now use that to actually uniform it into 5 classes. But in this one, you are human being. When we say machine learning, the way you used to see me, the first day you saw me, you saw me and, oh, this is this guy. That was the first time you saw me. The second day you meet me again, I didn't introduce myself to you again. You probably, your brain already automatically tell you this is who this guy is. So what you are trying to do now is that you are training the machine to understand, using this to understand what you're trying to say. If you look at this picture here, you know, raster data uses grid and grid cell to understand that this is what this means, like this is the interpretation of this on the image. So it uses grid and grid cell to show, as in represent whatever it is, represent the either satellite imagery or whatever. So it uses grid and grid cell. So if you look here, what you are trying to say is that if you look closely, you can see these pixels here. So it means that if, for example, where you have this, you are trying to tell this that any place you see this type of thing, recognize them as bare soil. For example, if I go to probably internet and say dog, and I say dog now, for example, you see now that the first time you see dog, how were you looking at dog? Maybe this is the dog you have at home. This is the dog here. Now, but your brain, the same way you train your brain works. When you see this is a dog. This is a dog. This is another dog. This is another dog. Look at another dog, and this is another dog. But what happened in your brain is that automatically your brain now knows that, oh, when you see something that have ear and this type of eyes, this is dog. When you see another dog like this, is this one dog? Your brain tell you, oh, this is dog because it have this kind of eye and like this. Now, in computer vision or machine learning, you train the machine, which is computer. You train what is not human being to be able to recognize that, oh, when you see this type of a thing, know that this is a dog. So what happens is that when you train it, and that is exactly what we're doing, we have a satellite imagery, and we are trying to make a kind of training where we say, okay, we know this thing as dog. Any place you see features that look like this, know that is dog. Any place you see features that look like this, know that is dog. Any other place you see features that look like this, know that is dog. Now what happens is that the machine, you are doing machine learning, you are training the machine that any time you see this kind of features like this, or recognize this as a dog. So what happens is that anytime he sees this, he says, oh, this is dog. Why? Because my brain have told me before that anytime I see this type of a thing, or I was told in school that this is what is called dog. So what happens is anytime he sees it, it will automatically recognize it as dog, and then that's what happened. So just like the way you save your picture for your facial scan, anytime you put your face there, it will automatically detect your face and unlock your phone. Why? Because you have trained your machine or the phone that anytime you see this picture, this is me, unlock my phone. So that's exactly what you're doing here, because you as a human being cannot go into these pixels to say this, what looks like this is a bare soil, what looks like this is a bare soil, what looks like this is a vegetation, or what looks like this is water body. So you take some sample and show the machine, oh, this place you see this kind of features, know that this is a water body. So what happened is that anytime he sees this water body, he says, oh, I was informed that anytime I see imagery that look like this, know that this is water body. When we'll be doing machine learning, when we'll be talking about machine learning, we will be doing this extensively because we are going to train machine to understand this is this. So you can use that like they will use facial recognition and rest of. So we are going to be using the computer vision now, that is machine learning, to understand, to train a machine to understand this is this pattern, based on the pattern, based on the color. But you know that remote sensing satellite imagery uses different way of making a kind of identification. For example, if I have a grid, a line that is drawn from 1 to 10, and what I have here is that this color here is, let me say this value of color is 7. So what will happen is that since the scale of 1 to 10, what means is that uh, using this, it is close to 10, it will automatically say this is what it is. What I mean is this: between the beginning of here where my mouse is to this place, if I tell you that from here to here is 10, what if I take what is the value of here? What your brain will do is that you tell me, oh, since here to here is 10, half of this is going to be 5. So what will happen is that based on this digital number or digital value of this imagery, which is in pixels, so what will happen is by the time you want to do this maximum likelihood classification, for the fact that you have told this thing that any place you see this kind of color, recognize this as urban area or built up area, what will happen is when it start running, it will go to this place and compare. I was told that this supposed to look like urban area. What is the closeness to it? Is it looking like it or not looking like it? It will say, based on the value or where I was given, this is actually looking like it. It will say, oh, this is urban area. So you are training the machine, or you are training the using this to train your machine to understand, when you see this color features, know that it is imagery. This imagery is built up area, water, a water body, or whatever it is. I don't know whether you understand what I'm trying to say.
Yes, I totally understand. I think
All
it's
right.
clear.
All right. So now what we did was we took a sample, that is sample training. We trained some samples to understand, oh, this is what this is what this is what is this. So use that sample we trained to generalize the rest of them, because I don't have the strength to start going to pixel by pixel to tell you, oh, this is water body, no, this is not water body, this is bare soil, oh, this is not bare soil. So what I will do is I will train some samples. When I use these samples, use this sample now to get the rest of the imagery for me. So this is exactly what we did. So we'll be using more of this kind of thing in different things as we go on, so that we will get to understand. But the whole thing is that this is the principle it works, and that is how it works. So the same way a small child brain is naturally trained that when he sees the mother, this is my mother, but I keep on looking at the mother, then anytime he sees, even when he sees the mother on the picture or phone, he or she will recognize this is my mother. That is the same way we are training this machine learning. So we are trying to learn to let the machine know that this is what it is at any point in time. Use it like this. So this is what we mean on this. And like we said, we have saved the training sample, the signature. So we have created a signature file. The next thing is either you go to ArcToolbox and go to maximize likelihood classification, or you come here and say maximize likelihood classification. So when this comes out, it's going to ask you for certain parameters. Now, maximum likelihood classification, perform a maximum likelihood classification on the set of raster bands and create a classified raster as an output. Now, the first thing it will ask us here is, which raster are you going to use? We are going to use this because this is the one we trained. So this is exactly the one we are going to use here, selected. Now it asks you for the signature, because you save the signature, which is what it will use now to understand the training you gave it. So you need to look for the signature where you save it. For me, I saved my own in somewhere here, so I'm going to look for that signature that I saved. So I'm going there to look for it, and when I get there, this is where I saved it, and then I save the signature here with king. So once I click on it, I can now open, and that will load the signature file here, as you can see. The next thing is ask you where are you going to output it? Sometimes Raster have issue with having a long name, so I am just going to reduce the name so that it will not be long again. Now rejection and acceptance, this choose the fraction of them which determines whether the cell will be classified based on its likelihood correctly to assign one of this. So you can read this when it is 0, which means that every cell will be classified. So I want every cell here to be classified, so I will leave it by 0 and 0 equal, and then it asks you another question here: what the output of the confidence interval. I'm going to explain the confidence interval soon, but the confidence interval actually shows us the certainty of the classification in the level of 14. Now with the lowest value representing the highest reliability. So if it is 0, means that, oh, I am very sure of this particular place. If it is 10, it means that, oh, I am not. If it is 14, means that, oh, I am not sure, because it says that with the lowest value representing the highest reliability. If there is no cell classifier at a particular confidence interval, the confidence interval will not be represented in the output raster. It may be in integer type. So the more close it is to 0, the more sure it is. So on this, I will want to save that because I would like to use that to be sure of what I'm doing. So I am going to save it. I'm going to write it confidence. So let me just write it anything, but I need it because I want to be sure of what you train. Like for example, there's a time you will see somebody, like, is it this person or not? Then the person will say, oh, I am 100% sure that this is the person. I am sure that this is the person. Why? So this is because maybe some features you are sure, or you answer question in the exam, you say, oh, I'm sure of what I do. How? Because of some of the parameters that probably you are not aware, you have determined that. But this is going to tell you, oh, based on what you trained me, I am very sure that when it is lower, I am sure of what I give you, or I am not sure. So with that, I will need that to use that to compare whether I'm sure or not. So I'm going to click OK, and then that is going to run this for me. So as you can see, so it is running. So it might take a bit time depending on the speed of your PC and the size of the data you're processing. So with that, it's going to make a classification and then give you output as well as the confidence interval to show you I am sure of what I classify based on what you trained me on. Is that okay?
Yeah, that is.
Okay. So we'll wait for it a bit. Wait for it a moment, and that is actually going to be out. So it's almost done. So it's done with the classification. So now it have classified it for us. Now you see here we have the classes we have from number 1 to number 5, and you can see the way it is. So this is what the classification look like. Now the next thing I want you to look at is the confidence interval. Remember what we said, that where we have lower number means we are more sure of what is there, and where we have red number means we are not sure, sort of things like that. So if you look here, this one shows you the confidence interval where I am sure or I am not sure based on what you train. So you can use it to assess what you train. Then this is how you can get that. Now under here, you can see this is what we trained. Now this is the pattern it forms. So you're able to see, oh, this is where there is water body. And if you look here, zoom close here, you will see where there is water body. Now on this, I'll open this and clear the training sample. And then another thing I could do is go to image analysis, which you can always get under your window here. If you click on it here, you see image analysis. If you click on the maximum, then and make this thing in bilinear, it get it clearer for you. So now I am going to use swipe tools to check. Now the imagery is turned on, the maximum likelihood is turned on. So I can now click on this to swipe to see what is under it. So I am swiping. Now why is it not working? Remember what I explained here. You need to make sure that while you are swiping, make sure that what is selected is the one on top. So what is on top here, MLS give. So now with this I can swap and I will see what is under. You see here, you can see the matching. You see here, you can see the matching. This is water body. It's purely, the water body is perfectly extracted. If you look here, you see that this is the bridge. There's a bridge across here. If you now roll out, you can see that two bridge. This bridge here, this bridge here. So what am I trying to say? You see now that we have actually used this to make a classification, extracting the water body the way it is, which is perfectly looking very nice. Look at where we have farmland. If you look here, you see that that place is where we actually have a farmland. You can see the way it is. So now look at where we have a forested area, like where we have a kind of forested area. And if you look at it, you see that the place we have forested area, you see here, because we trained it there, is looking forested, like forested area. Then the last one is water. Now how do we make all this? So we go down here, go to the attribute information, open up attribute information like this, and go here and create. For me, I'll go here under here and add a new field. And what field am I adding? I need to make this class, define this class. So I'll click here and I will say class, and then open up here, go to what is it? It is a test file, and click this to add this. So what am I trying to do? I want to put them in class. Now how do I put them in class first? I will now edit this raster. So go to right click, start editing, and now here the value here is there. So I'm going to open up this training sample again, and I'm going to import the training sample that I trained here and open it like this. It comes here. The one that have value 1 is bare solid. I'll go here, value 1 bare solid. I'm going to paste it. The one that have 2 is built up area. I'll click on this, copy again, go to built up area and paste. The one here, farmland, click here, copy, do the same thing here and paste. Then go here, do vegetation, so copy, do the same thing again, paste. Go here, do water body, copy, do the same thing again here and paste. Now I can now go and stop editing. So for me, I'll go here and say stop editing. It asks me, do you want to save? I'll say yes. Then the next thing is to clear this training sample, and then I can now close this. And if I go down to in here, then I can say to classify them based on the classes. So I'll go to symbology, change this to class, and add all layers like this. You can see built up area here. I can select the color I want it to flow with, so which is also based on you. Select the color you want it, or based on what type of things you're doing. So if you click apply, you should be able to see the way the color is. So for me, I like the color I always like, so I can go ahead and select the color I want. So depending on you, so whichever you want it, so you go ahead with. As for me, I always like this color, so I can change the way it looks. So with this, I can click OK, and that's actually going to put it for me the way the color looks like. So in bare soil, you can also make the color, for example here where you have bare soil, you can change the color to what you want. Built up area, probably supposed to be in red, let's put it in red. Farmland, supposed to be looking like this, you change it like that. Vegetation supposed to be looking a very thicker one, you change it like that. Then waterway supposed to be looking blue, you also change to whatever you want. So this is a way you can make it so that when you now zoom open here, you should be able to see the way a map looks, where you have bare soil, where you have built up area, and rest of them. So when you are done, you now, let me save. Now the other things you can do is you can switch to your layer and then form the map by putting on the boundary the way it is. So for me, I can put like this and zoom to layer and then fit this to paper, and that's going to come up like this. And you can see here we have the the classes here as best built up area, farmland, vegetation, and rest of them. So I can get this done. Now another thing I could do is I want to calculate the area. So what I'm going to do is I'll go to Arc toolbox here, and then I'll go to conversion tools here, and then I'll under conversion tools. So under conversion tools here, I will say from raster, I want to convert it from raster to polygon. Now there are two things I want us to see here. When you convert from raster to polygon, let me use the magnitude, this one, and then I want to use the value of classes here. If I check this, there's different thing. If I check this, if I don't check that, it's going to give me in two different patch. Now to understand this, I am not going to check this, I'm going to run it. To show us the difference between both of them, I'm going to run it. Then you will see that it's going to bring these things into individual parts, not minding like the whether the classes. So it's going to give me wherever they are located. It's not going to merge them as one feature part. So it means that if you go to that attribute table, you are going to have many patches because it is not going to form them as one. So that is when you didn't check that particular, that's supposed to create a patch. So that is what is going to happen there. So wait for it to finish up.
I think I prefer this one to be on supervised because
Yeah, this is
the unsupervised you have to manually do everything by yourself, like trying to confirm, and you're not really too sure about your process of classifying of classification. So I think this one is way better than
yeah
unsupervised.
yeah, this is better in several, especially when you have a good imagery. The only challenge we have sometimes is when we don't have good imagery. So but when we have a good image, this is better because this one you can be sure of what you do. Even sometimes you pick a point. Like sometimes there is a project I did on urban agriculture where I have to go to use GPS to pick some point, high GPS to pick some point of urban, where we have urban agriculture, and then overlay it on it and use that point to train the imagery. So you have more accurate data, especially when you have a good satellite imagery, because this one you supervise it yourself and you know what is there. It's better than when you just say randomly, give me this number of classification. So it goes in and do whatever it likes and give you. So where that one is just better is maybe where you just don't have, maybe you just want to know a vegetated area and non-vegetated area. So this you can use that just to, for a kind of, give me this in this group and this in this category. But if you are looking for a particular feature, you mean I'm interested in water body and I need to train this to, for this to be sure that, oh, this is water body, this is vegetation, this, so you are sure you want to really want to do such kind of research. So you have, it's better you train them so that you are sure of what you are doing. You get that?
Yeah, yeah.
Yeah, this is actually taking time because it have to create a different patches. So but why I wanted to show also, and why I'm taking that, like I want to show us this, is because I want you to see the importance, like why you need to click the other one. Because if you don't click it, you might see, you can see the difference between them. The time it take it to process is number one. Now if you see the way it is loading, you see that it is of many patches, and that is really taking time. And you see it is loading very slow, because if you open the attribute table now, you will see that you have up to many this thing in the attribute table, so which is not really probably what we need to start working on. So on this I am going now to show you. So go here, right click on it and open it up like this. You see that you have this kind of table. about 73,730, as in 732,000 patches. So this is not what we are going to be going into to be doing. So that's not okay for me. So because of that, I just showed you this so that by the next time you want to do it yourself, you have to like understand why you need to, why you are selecting to convert to polygon here, why you are making this kind of selection, and why it is important you say create a multi-part feature. So with this, you can create it in such a way that it's going to get patch and form single one. So you see before we have 732,000 patches, but now we're only going to have 5, and that is going strictly to actually get that like the it done for you the way it's supposed to be, and calculate the area for you. You can say the a total area for this is this, and total area for this is this. So that is better than when you didn't click there.
Mm.
So wait for it. This is going to be faster, number one. This is going to be better, so you can see it's done. So this is faster, and you see it is done. Now if you go to the property, you're only going to have 5 because you have these classes of 5, and you see here you have calculated the areas in meters, and then you can see it only group it into 5. So this is the better way, and it is faster. So with this, you can now go here. If you are doing analysis, you go here, you do selection, and you say select all, and all will be selected, and then we wait for it to load because there are so much um, it have so much part. So all of them will be selected, and when it is selected like this, the next thing you can do is you can say right click again here, go to selection and say copy record for the selected features, which I've copied. Now I can use Python, which we are going to advance more, like part of the things we did in our assignment. We can use Python to get it done, or we can just go to Excel here, and then I have copied it, and I'm going to paste that, and you can see here now that I've pasted this, and I've also pasted this. So you can see here I can decide to remove this here, remove the grid from here to here. I can take them away, and then here the shape, I don't really need the shape, I will remove it. Then here I can add the insert at the right hand side, and I can say percentage, for example. Then the next thing I need to do is here, this is area, so I'm going just to type area here, and this is in square meters. So I'm just going to select here to here and press Ctrl Q, and that's going to show me this. I'll press here total, and I'll scroll right again, and I'll press total. So this is the percentage here. So you can see this have already calculated the percentage for me, and as you can see, so very perfect and quick. So this is the percentage: bare soil 54, built up area 32, farmland 7, vegetation and water 0.2%. So if you add up this by pressing alternate equal to, you should be able to have the area, the total as 100, and if you drag this one to the right hand side, you see the total area here, and if you divide this thing here by 10,000, you can see how many hectares the place we worked on. So this is about this number of hectares. So this is a perfect way you can do supervised classification, and if you do that for 2010, 2020, 2002, 2000, you can make a comparison analysis between them to see what have changed over time, what have changed and what have not changed. So this is a way to do a supervised classification, and then be able to use that to make decision on the rest of them. Is that okay?
Yes, that's a perfectly fine. Also, I tried with this thing, I tried this stuff, this percentage stuff, with the unsupervised, the way it did it. Just that I was not so sure about that my classification because of the way I did it. I was not really sure that the places I picked as the farmland and the rest, I was not too sure about it because of how the way it is. But this one is perfectly understood.
Oh, that's yeah. So you can try that out. I think I will be telling us what we need to do, but we try it out. Then if you have challenge, you let me know while I tell us what we are going to do about it. So on this, so I want you to kind of make a kind of um, practice, and then while I also tell us what we are going to do, and then I will let us know what we will do on that. Is that okay?
Yeah, no, thank you.
All right. So I think this is pretty much of it for today, and then we will meet next time to continue with our Python. But for now, if you have any question, you can ask. Otherwise, we can a bit drop it here.
No